Hello and welcome to my channel Networking with H. In this video, I will do a lab on how to configure OSPF version 2 and then verify the OSPF neighborship and routes learned via OSPF. For this, I have a small topology in which I have three routers, R1, R2 and R3 connected to each other. And the subnet which I have used, as you can see in the topology between R1 and R2, I have used 172.16.1.0. And between R2 and R3, I have used 172.16.2.0/24. Our objective in this lab will be to configure OSPF along with the router ID on these three routers so that these three routers can be identified uniquely. Then we will verify the OSPF adjacency and then routes learned via OSPF and then test the connectivity between R1 and R3. So the IP addresses are configured as shown in the table, as I have said earlier. And then in case if you need a step-by-step guide, I'll be happy to help you. And also I have this lab available in my course in Udemy. So the first thing that we need to do is we need to configure the IP addresses. I have already configured the IP addresses pre-configured on the packet tracer. So my objective is to show you the OSPF functionality in this lab. So let me hop on to the OSPF part. The first thing what we need to do is enable the OSPF. And the command to enable the OSPF is router OSPF1. I mean, you need to define the process ID. So let me hop on to R1 and then get into the global configuration mode and then enable OSPF. You can give any ID, but it's up to you what you want to give. Similarly on R2, you can give any number from 1 to 65535. It's locally unique to the router. And then let me hop on to R3. Okay, so this enables the OSPF. Then the next part is to set the router ID. To set the router ID, the command is under the OSPF configuration mode, you need to define the router ID. So let me go on to the router R1 and then define the router ID. You can define it in any way you want, like you can define 1, 2, 3, 4, but 1.1.1.1, this resembles the R1. So that's why I have given a unique ID. So router ID 1.1.1.1. Similarly for R2, I will assign it as 2.2.2. And similarly for R3, I will assign it as 3.3. router ID 3.3.3. Okay. So this completes our router ID configuration part. Then the third thing what we need to do is assign the networks to OSPF. We need to advertise our links. If you have any more like loopback addresses, if you want to advertise, you can advertise that as well. But right now in this lab, I will advertise only the links connected to my router. On R1, I have 172.16.1.0. If you see the topology here, 172.16.1.0.1 is configured on R1. So I will advertise it as 172.16.1.0. You can advertise a single IP as well if you want to limit the advertisement. Like for example, .1. It's all in the wildcard mask. You can play with the wildcard mask. If you want to advertise a full subnet, if you want to advertise one IP, then you need to mention the wildcard mask as 0. If for example, if you want to advertise only 1, then you can mention it as 0. Or if you want to advertise the subnet, you can mention it as 55. And then you need to specify the area. We are using area 0 for all the three routers. So I will specify it as area 0. Similarly, I will hop on to R2 and then advertise both the networks here. Since R2 is connected to both the networks 172.16.1.0 and 172.16.2.0, I will advertise both 0.0.255 area 0, and then as soon as you enter the network command, the neighbor is up. Similarly, I will advertise area, another interface. Actually, this message on your log confirms that the neighborship is up with R1. Now, since we have not configured the network, we didn't advertise the network on R3, the neighbor is not up yet. So let me do that as well. 172, the network which we have is 2.0 and the subnet mask is 255 area 0. This should bring the neighbor up. As you can see, the neighbor is already up. Okay, so this completes our OSPF configuration part. Let's verify the neighbor status first. And to verify the neighbor status, the command is show IP OSPF neighbor. Let me get back to the privilege mode. Show IP OSPF neighbor. Now we are on R1. So our neighbor is R2. And the router ID of that neighbor is 2.2.2.2. And then you can see the address through which it has formed the neighbor and the interface and the state of the neighbor, it's full. Similarly, let me hop on to the R2 and then check. Here you will find two neighbors. First one is R1 and the second one is R3. Both are in full state. Then let me hop on to R3 as well and show you. Show IP OSPF neighbor. On R3, the neighbor is 2.2.2. Another important command that we need to check is show IP route OSPF. Now let me hop on to R1 and see if I'm learning the route of R3. Show IP route OSPF. Here you go. You can see the OSPF learned route, that is 172.16.2.0, and the AD is 110 via so and so subnet and interfaces. If you see the show IP route command, it will list all the routes with connected routes, and then you can identify the OSPF route with O, as that is mentioned in the legend section, code section. Another command is show IP OSPF. If you want to know what is the router ID of your device, then this is the command, show IP OSPF. The first line itself will tell you your process ID is so and so, and the router ID is 1.1.1.1. Other important parameters are also available in this command, show IP OSPF, which it will include the number of LSAs, the number of SPF algorithm it has executed, whether the authentication has been enabled. All those details are available in show IP OSPF command. Another important command which I will tell you is show IP protocols. This will list whatever protocols are running. Right now we are running only OSPF, so it will show you what networks am I advertising, how many paths are available, number of areas in this router. All those details will be there, and it will tell you the default distance. Then the last part is the connectivity part. We need to ping from R1 to R3. 172.16.2.2. This is the interface IP of R3 connected to R2. As you can see, I can successfully ping. Let me do a trace route as well to show you how is it passing. It is passing from the interface connected between R1 and R2, and then it goes to R2 and R3. The step-by-step guide I can share you if you need it, or you can also look into my Udemy course on, CCNA course on Udemy. This includes all the detailed lab related to all the topics, and also it also includes practice exam for you to help pass your CCNA certification exam as well. Please do check out and enroll, and I'll be glad to help you there. That's it for this session. I hope this was informative for you. Thank you for watching. Please do like, share, and subscribe.